welcome to my podcast. Today, my guest is Jahnavi Iyengar from Ireland. She is an electrical engineer and is currently pursuing her master's in energy systems. Hi, Jahnavi. Welcome to my show.
Hi Vedant, thank you for having me on your show.
I'm excited to have you on my show.
Thank you, me too. I'm really excited to be here too.
So, in my research, I learned that engineering is all about solving problems. I am curious to know what type of problems do electrical engineers like you solve?
All right, so electrical engineer is actually a vast field. It contains design, develop, and testing of all the power system equipment. It can be a simple electrical appliance at home, or it can be a huge power system that you design. So with electricity comes different problems such as transmission problems where there is an issue with transmission of electricity, or you can have appliances issue that can be as simple as that. So as an electrical engineer, we try to solve every problem that is associated, be it small or big, with the power system equipment. It can be a nation or just in the house.
Wow, those are a lot of problems to solve, and they are so complex.
Yes, they are.
What is electricity and where does it come from?
So to understand electricity, we have to get into the atomic structure. So as it is well known that any atom has three types of charges, let us say positive, negative, and neutral charges. So what happens is that when the negative charges that are known as electrons, when they move, the movement of the charges becomes electricity. It is not something that you can see, it is just something that you can feel. So when the negative charges flow in one particular direction, it becomes electricity. So electricity is nothing but the flow of electrons, that is the negatively charged particles, and from in one particular direction. There is also known as static electricity, where there is no flow of charges and the charged particles just accumulate, which are separated by an insulator. So there are positive charges at one point and negative charges on the opposite end, and there is an insulating material in between. So essentially, this is electricity.
What is an atom?
All right, so an atom is the smallest unit of anything that we see. It can be, so our body or this universe or the computer, anything is made up of small structures known as atoms. They have like a nucleus in between, which contains the positive and neutral charges, and the negative charges revolve around it.
In my research, I learned that electricity can pass through some materials and cannot pass through the others. Why is it so?
In everything that we speak of as electricity, you can just consider it to be water. You can equate electricity to the flow of water. So water can flow through some materials, water cannot flow through some materials. So if you have a cotton cloth, water goes through, right? And if you have something else, the water passes through very slowly or it does not pass through. So electricity is the same. When you resist any movement, it becomes the least conducting element. And when you have less resistance, that means you allow the electricity to pass through. Since it is just the flow of charges, it is a flow of particles, the material decides to whether allow it or it decides to stop it. So it all boils down to the point of having resistance of the material, which is an intrinsic property.
If there's a piece of glass, can electricity go through that?
If you have glass, it does not go through easily, so it is known as an insulator. But if you have copper, it goes through easily. You can definitely conduct electricity through glass, but it is highly difficult to do that. You need much more electricity if you have to pass it through glass. So essentially, when you're talking about the daily objects, glass is considered to not conduct electricity.
I have seen signs that say danger, high voltage. Why is it dangerous?
All right. So, like I said, electricity can or cannot pass through certain materials. So human body also has electricity passing inside our body, and that is of certain amount. Electricity can be measured through something known as the voltage. So when I talked about static electricity, where there are charged particles accumulated, separated by an insulator, that is known as the voltage. So the amount of voltage determines if it is danger or if it is not. So when you see a board that says danger, that means it's high voltage. And if that much electricity passes through the human body, it can either result in just a minor electric shock, or it can result in serious injuries, such as even considering death. So the amount of electricity that passes through our body when you touch something like that. But it does not mean that our body cannot conduct electricity. So when you see a sign like that, you just need to stay away from it, because it is such high power that the human body cannot tolerate it.
So you're saying right now, when I'm speaking right now, electricity is passing through me and I can't feel it?
Yes. So the electricity is within you. The brain cells, the neurons, or your body is made up of cells, right? The human cells. Yes. So from the brain, whatever you think, or say when you want to talk, you're talking right now, your brain is sending signals to your mouth to talk. That means it is sending electrical impulses. That is nothing but electricity, but you cannot feel it. It is very less in magnitude.
Wow, that sounds scary.
Yes, but it is not. It happens every day, every minute.
I have seen birds sit on electricity wires. Why don't they get electricity shock?
Electricity can flow only from a higher charge particle, from a higher voltage to a low voltage. So when the birds sit on one line, there is no difference in it. So that means the electricity that is flowing will not flow through the bird, but it will just flow directly through the copper wire, or the wire that the electricity is flowing. So that is why the birds do not get electrocuted. In fact, humans too, if you just hang only on one line, you will not get electrocuted. But it should not be done, because if at all, if you touch one wire and you stand on the ground, that means the electricity will flow. So humans or anything, even birds, if you're in contact with only one line, you will not get electrocuted. But if you should have actually seen that, you can see that bats have a lot of electrocutions, and that is because bats have large wings, and when they sit on the wire, usually the wings touch two wires, and that means there is a difference of voltage from a high voltage to a low voltage. So that means the electricity will flow through the bat and then they get electrocuted.
Why are there three wires? And I have also noticed that they aren't straight, like one next to the other. They're shaped in a triangle.
There are two types of electrical transmission. Transmission is nothing but carrying electricity from one place to another. So there are two types that you can do it. It is known as single phase, and the other one is known as three phase. So single phase has only two wires, and three phase that you see generally has three wires. Any power transmission that you see has a lot of losses. So having three wire system just diminishes the losses, and it is easier to transmit when you're transmitting it from generating stations to your houses. That is why you have just three wires.
Why are plugs and sockets different in different countries?
There is no technical rule as to why plugs and sockets are different. It is just because every country has its own adoption. So in the 19th century, when electricity was commercialized, there was only two pin plugs. That means a plug had only 2 points. But then came three pin plug for more safety. So the three pin plug has an earth wire that connects it to the earth. It protects the appliances from getting spoiled if there is a difference in voltage. So now the world has at least 15 plug and wall socket styles. It is mainly due to political and economic issues. The IEC, that is the International Electrotechnical Commission, they came up with a type N, that is the universal power plug, for the entire world to have just one plug. But no one uses it. Only Brazil did adopt it. None of the other countries wanted to accept it. So they started manufacturing their own plugs and sockets. And that is why we see a lot of changes.
So here in Singapore, there are the 3 pins. So you're saying
Yes.
earlier there used to be 2 pins only, and then 3 pins came here?
Yes.
Oh.
So it is earlier in the 19th century, there were only 2 pins everywhere. So it had 2 pins everywhere, and everyone started to adopt it. But when the matter of safety came into picture, and when people understood electricity much better, then they started to manufacture their own plug points and their own pins and sockets.
When phone chargers are plugged in and we touch the charging pin, why don't we get a shock?
So like I said, you will not get a shock if the electricity is very less, correct? So when you touch a phone charger, the phone charges at very low voltages, and that is the voltage that the human body cannot even detect. It's not that you're not getting shocked. The electricity does flow through you, but you will not feel it. It's only because it is of such low magnitude.
How do batteries give electricity?
All right, so electricity, you should understand that it is just energy, okay? And energy can be stored or converted. You have different types of energy like chemical energy, electrical energy, heat energy. If you just feel that something is hot, that is heat energy. So in batteries, what happens is you have electrical energy that flows through the plugs in your houses, and you convert it to chemical energy. So electrical energy, you take it from the plug points in your house and you plug the battery into those. In the battery, you convert it to chemical energy and you store it. And whenever you need it, you are going to discharge the battery. So that means the positive and the negative charges in an atom, you just make the movement flow so that you have electricity at the end of the day. So when you need electricity from a battery, you're just going to make the charges flow inside the battery and you're going to take out the electricity.
So the positive and negative is the plus and minus, right?
Yes. So when I say an atom, it has the plus and minus in it. So the movement of the minus signs, that is the negatively charged neutrons is electricity.
What motivated you to study about electricity? As a child, what did you want to be?
As a child, I've always wanted to be a scientist, but it was different for me. As a child, I did not know what a scientist is. I thought wearing white coats and having beakers was scientist. So that is what I wanted to be. But as and when I grew up, I was very fascinated by the concept of electricity because it is not something that you can see, but it is there. So I was very fascinated. And I guess in high school, I just decided that I like physics and electrical engineering was a good chance for me to be in touch with physics. So I think that is why I chose electrical engineering.
What
Yeah.
are your hobbies?
I like to sing and dance and read books. So these three have been from childhood. And I'd also like to try new things. So I tried fencing last year and I'd like to go skydiving. So I guess just that. But singing and dancing would be my main hobby.
Even I like singing um, and learning new things, and
Oh, yeah, I've
also
heard you
reading
sing.
books.
I know. I've heard you sing. You sing really beautifully.
Thank you. What is your favorite food?
Favorite food?
Mm-hmm.
Um, Anything South Indian. That is my comfort food. I like rice, rasam with curd rice.
I like everything.
I do like pastas and pizzas, but I
Same,
know that
I
you
love
do.
pasta. I love pasta and pizza.
I know you do. I like them too, but at the end of the day, when I've had all the pastas and pizzas, I like to come home and have a bowl of curd rice.
Thank you so much for coming on my show.
Thank you, Vedant. It's been nice to be on your show.
Yeah, I like this interview.
Thank you. Thank you, audience, and thank you, Vedant.
Dear listeners, follow my Facebook page, Curious Vedanth, to get updates on the upcoming episodes. To listen at leisure on your phone and get notified about future episodes, subscribe by searching for Curious Vedanth wherever you get your podcasts, such as Apple Podcasts, Spotify, Stitcher, Google Podcasts, and many more. You can also listen to my show on CuriousVedant.com. Thank you for listening to Curious Vedant, and don't forget to rate and leave comments